Hi, I'm Johnny, and today we will be looking at a question inside the McGraw-Hill-Ryerson Calculus and Vectors 12 textbook. We are looking at Unit 4, Derivatives of Sinusoidal Functions, and the question is on page 241, number 1. The question reads, an AC-DC coupled circuit produces a current described by the function I of t equals 60 cos t plus 25, where t is time in seconds and I is the current in amperes at time t. Part A says, find the maximum and minimum currents and the times at which they occur. Part B says, for the given current, determine 1. The period t in seconds, 2. The frequency f in hertz, and 3. The amplitude a in amperes. For part A, we must determine the maximum and minimum currents for the function and when they occur. When examining the graph for the function I of t, we can see that there are an infinite number of maximum and minimum values. The first step to solving this question would be to realize that the times at which the maximum and minimum values occur on the graph of the original function will be equal to the times at which the graph of the derivative function equals 0. This is due to the fact that the derivative function models the slope of the original function. At the maximum and minimum values of the original function, the slope is 0. Therefore, the graph of the derivative function at these times will have a value of 0. In other words, the point will be on the x-axis. So in order to solve this question, we must find the derivative of the original function. The a value, 60, will remain the same, but the cosine t will become its derivative, negative sine t. Finally, the 25 will be eliminated as it is a constant, and we will be left with the derivative function, which is I prime of t equals negative 60 sine t. Next, since we know that the points we are looking for on the derivative function graph must have a y value of 0, we can set the derivative function to 0, then isolate and solve for t. So we have 0 equals negative 60 sine t. Then we can divide negative 60 from both sides to get rid of the a value, so we are left with 0 equals sine t. Then we can rearrange to solve for t. So we have t equals the inverse sine of 0. So the next step is to find the t values where sine is equal to 0. This can be done by examining a basic sine graph. Here we can see that there is an infinite number of solutions, or x-intercepts, all occurring in multiples of pi. For example, negative 2 pi, negative pi, 0, pi, and 2 pi. Now we must choose two t values to plug into the original function. One will be the time at which a maximum current occurs, while the other will be a time at which the minimum current occurs. For the first time, I have chosen t equals pi. So we plug this into the original function, and we get I of pi equals 60 cos pi plus 25. When referring to a basic cos graph, we can see that cos at pi is equal to negative 1. So we now have I of pi equals 60 times negative 1 plus 25. Then we are left with I of pi equals negative 35. This means that the minimum current of negative 35 amps will occur at t equals pi, plus or minus any multiple of the period, which is 2 pi. Finally, we must solve for when the maximum current occurs by using the second t value, which is 2 pi. I of 2 pi equals 60 cos 2 pi plus 25. Once again, by referring to a basic cosine graph, cos of 2 pi is equal to 1. So we have I of 2 pi equals 60 times 1 plus 25. We are then left with I of 2 pi equals 85. Therefore, a maximum current of 85 amps will occur at t equals 2 pi plus or minus any multiple of the period, which is once again 2 pi. For part B of the question, we are asked to first determine the period of the function. This can be done by using the simple equation period, or t equals 2 pi over b. When looking at the original function, we can see that there is no b value shown, or in other words, there is a b value of 1. Therefore, we plug in 1 into the equation. So we have t equals 2 pi over 1, which simplifies to t equals 2 pi seconds, or t equals 6.28 seconds. Therefore, the period of the function I of t is about 6.28 seconds. Next, we are asked to determine the frequency of the function. This can be done by using the equation f, or frequency, equals 1 over t, or period. From the previous part of the question, we determined that the period was 2 pi, so we can plug this into the equation. So we have f equals 1 over 2 pi, which can be simplified to f equals 0.159. Therefore, the frequency of the function I of t is about 0.159 Hertz. Finally, the last part of the question asks us to determine the amplitude of the function. We can do this in two ways. The first way being that we use the equation A, or amplitude, equals the maximum value minus the minimum value divided by 2. Now we determine these two values in part A of the question, which is a maximum of 85 amps and a minimum of negative 35 amps. So we can plug this into the equation. A equals 85 minus negative 35 divided by 2. By simplifying, we are left with A equals 60. The other way of solving for amplitude is by looking at the function and finding the A value. This A value is equivalent to the amplitude. In this case, the A value is 60. Therefore, the amplitude of the function I of t is 60 amps. Thanks for watching, and I hope this assisted you in your studies of grade 12 calculus and vectors.